And hello, everybody. Welcome back to part two. Promise made is a promise kept. I said we would start with IMDb, and here we are, in-memory databases. This is a database management system that's going to store the entire database in RAM, that random access memory. Because it's all in electrons, it's very fast, right? It's much faster than storing data in a secondary storage location and having to pull it forward like in a hard drive or a flash drive. It does decrease, there's a corresponding decrease in RAM costs as you increase RAM capacity. So it's really very interesting. I will say the only issue is if you lose power, right? So you want to back up that data along the way. In-memory databases come in multiple forms. These are some of the leading providers along the way. Now, continuing with analytics and business intelligence, there's a difference between BI and analytics. Is that BI is used for using historical data to tell you accurately what happened or to make a prediction about your business right now, right? Which is useful. Analytics is going to be the approach that does that extensive data mining, but it's going to make predictions that end up quantitatively addressed, fact-based about the future. Quantitatively predictions about the future. So it's kind of interesting. These are some of the benefits of BI and analytics. My company does it to detect fraud. We use what's called a risk assessment engine, or RAE, but we're using analytics to detect fraud and to report and make some automated decision making in that process. We can improve forecasting, increase sales, optimize operations, and hopefully reduce costs. From a business perspective, all good things. So how does all this get done? Where's the magic? Well, the magic happens really in terms of a data scientist. This is an individual who combines strong business acumen, a deep understanding of analytics, and a healthy appreciation for the limits, just as important as the strengths, of data, tools, and techniques to deliver real improvements to decision making. Notice I didn't say the data was making the decision, but it's improvement to decision making. There are rigorous educational requirements for a data scientist. If you look on the Moodle site, you'll notice that I added a link to the Glassdoor data scientist website where you can see what the career field's about. So you, as an information systems manager, may either have been or will be a data scientist, or you will manage data scientists in that role along the way. So it's worth checking out. Now, components for effective BI and analytics are three, right? The existence of a solid database management program, including governance. And to me, all of this should fall under the compliance framework within an organization. And then, of course, you want to hire creative data scientists and make a strong commitment to data-driven decision making, which is based on experience, culture, risk, etc., in addition to the data that is provided. So just a quick note on some quiz action here. As you recall, I said a data warehouse was a large database that holds business information from many sources across the enterprise that cover all of the company's processes, products, and customers. You'll notice that I also, as a reminder, that a NoSQL database describes an entity that can store and retrieve data using a modeling means that's other than this two-dimensional tabular vertical and horizontal relational database. That's a NoSQL database. As you recall, I mentioned that NoSQL databases do not require a predefined schema, one of their advantages, very flexible, and that the educational requirements for the data scientists that you hire are quite rigorous. Now, continuing with business intelligence and analytics, here are some of the tools that you could choose from. You'll see a description of this also in the textbook, but as an information systems manager, these are things you'd want to consider if you were asked for recommendations. Now, descriptive analysis is the next topic. And as a preliminary data processing stage, descriptive analysis is used to identify patterns in the data. And you're going to answer questions such as who, what, where, when, and to what extent, right? And so there are two types of descriptive analytics, is visual analytics and regression analytics. A little bit about visual analytics. This is the presentation of data in a pictorial or graphical format. And there are a lot of, for a word cloud becomes one of those. That's a depiction of a group of words that have been grouped together because of the frequency of occurrence. I've been at conferences where I've been asked to text a response to the speaker's answers, and it creates a word cloud on the screen automatically. Kind of neat. There's also the conversion tunnel, right? And that's a graphical representation that summarizes the steps that the consumer takes to making the decision to buy our product and become a customer. So kind of neat. Here's a picture of the word cloud, and here is a picture of the conversion funnel. I know you recognize both of those from your readings. Now, descriptive analysis can create this data visualization using data visualization software. Some of the more common products are Google Charts, iCharts, Tableau, many of us use, right? And so this is an example of a scatter plot that shows the relationship between age and weight. Notice the scatter plot is always going to have a vertical and a horizontal. It's two-dimensional, and it's demonstrating, in this case, the relationship between weight and age along the way as part of descriptive analysis. Now, as I mentioned, regression analysis was the other form of descriptive analysis. And so in regression analysis, it is looking at that relationship between a dependent variable, say y, and one or more independent variables, x1, x2, etc. And so it gives you an awful lot of capability. It enables users to determine what factors are independent variables, which matter most, which can be ignored, that sort of thing. So it's really quite powerful. The regression equation can be used to make predictions. That's why we do regression analysis. And you would hire a regression specialist to do that in your company. Now, there are a couple of types. There's predictive analysis and time series. So predictive analysis is a set of techniques that you would apply to analyze the current data and identify any future possibilities or trends. And then, of course, within your company, you would make predictions based on those. And it employs an awful lot of techniques. So you'd want to hire somebody with an expert in this capacity. But the key is that it captures the relationships among the many variables in a problem. Sometimes we call this like design for X would be similar. Now, time series analysis is a system of statistical methods used to analyze time series data, right? So, and we extract meaningful time series analysis to solve a problem. It'll help us understand what the underlying forces are to a particular trend in a series of data points. So really quite interesting there as well. I do want to also move on to data mining. Data mining is a BI analytics tool, and it's used to explore a large amount of data for those hidden patterns to predict the future trends and behavior used in decision making. When used appropriately, I think data mining enables organizations to make predictions that will that will help managers to be more proactive. That's what data mining is going to do for you. And there are three common techniques: association, right, how things associated, neural computing, and case reasoning computing. Case reasoning it's a historical if-then-else case to find patterns. Neural computing is using that historical data for pattern and looking for patterns to make predictions. And then association, as I said, there's a specialized set of algorithms that link things together through forms and statistical rules and relationship items to create the association. Okay, let's see. Here is a figure 6-8. This is the cross-industry process for data mining. This is a 6-phase structured approach for the planning and execution of a data mining project. So if somebody asked you from an information systems manager perspective, how would you approach, what would be your approach to data mining? This would be the 6-step process that I would go for. And there are goals associated with each step along the way. Now, optimization becomes key to what we are doing. Optimization techniques are used every day in every organization, right? If you're not getting better, you're falling behind. And so we often use it to allocate scarce resources, for example, as in a way to minimize costs or maximize benefits or profit. So I can use a genetic algorithm, for example, and that employs this natural selection-like process to find solutions that optimize a research problem. The most famous approach to all that is linear programming, and the UONA has a course in linear programming called Deterministic Operations Research. It's fabulous. It's linear programming, and it helps you maximize the decision. So linear programming is finding that first you'll graph a set of okay decisions that would be acceptable, but in that graph on the outlier at the edge, you will find the optimal solutions. And so what you'll do is you'll create a linear expression based on the variables, the constraints in your, cost constraint, production constraint, and you will create, that linear expression becomes an objective function. That's your objective based around those constraints. Really kind of neat. There's a whole class dedicated to that in UONA, which you may take. You get a lot out of it, I have no doubt. Okay, figure 6.9 just walks us through the multi-step process of the genetic algorithm that we already talked about. I did want to touch on simulation. Simulation comes in a couple of forms. Scenario analysis is one of them, and that's a process for predicting future values based on a potential event, what might happen. If then. Scenario, what's the scenario? Well, if then. Monte Carlo analysis is a little bit different. That's the simulation that enables you to see the spectrum of possible outcomes. So I could take my project schedule, I could take my project constraints, my assumptions, my timelines, etc., put them all into this Monte Carlo program, and it would spit out the critical path of my schedule, what's the expected end date of my project, etc. So Monte Carlo is a powerful tool. It requires a lot of data, and it's based on probability distribution. But it will give you some estimates to work from based on the simulation. Monte Carlo, it's gambling, right? Just like Monte Carlo, the casino. Okay. And then, of course, text and video analysis, right? Text analysis is a process of extracting value from large quantities of unstructured text data in terms of consumer comments, etc. and video analysis does similar from Video Insights. Okay, that pretty much wraps it up. I appreciate your time, and I will see you online